flip over. Great. You can see my slides, Kaya? Yep. Yep, all good. All right, good job. So do shout out at any point if anything I talk about you're not too sure about, if you've got any questions. But what we're doing today is just having a look at the topic of measurement, which we've been looking at since we've been in lockdown, just checking in with how we are across all the things we've been looking at, just giving you a few pointers on things, because tomorrow I've set up that there is a little bit of a progress check, a little quiz just for you to do, just so we can see where everyone's up to. And then we know where everyone is, we know where we are coming back into school, and we can just pick up and make sure we're in the right place and, you know, dealing with any bits that we need to. If any bits have been trickier, we can have a look at those ones. Things that we know everyone's happy with, that's all great, but then we can just have a look at the other bits and make sure everyone's happy there. So that's what it's about, really, just making sure we can check in and everyone's okay and we know where to pick up. So what we've covered quite a lot, actually, while we've been looking at this topic. So we've been looking at perimeter, the distance all the way around the outside of shapes. We've been looking at area, the space covered by a shape, the amount of space it fills, two-dimensional shape. We've looked at rectangles, so how we get perimeter and area of rectangles. We've looked at parallelograms, again, how we get areas of those, triangles, again, areas for triangles and trapezia. And then we went on to look at circles, where pi was involved, and composite shapes, which is those shapes where we've knocked together a few things, and there are ways we can use some of the methods that we've got for other shapes to build up the areas or the perimeters. And the cuboids, then we started to get into volume of cuboids, so prisms as well, and cylinders. Okay, so that's really the things that we've covered. We've covered a lot. We've got perimeter, area, volume, and then the special shapes that we've looked at. With the volumes, we've looked at cuboids, prisms, and cylinders. Okay, so the key thing for us in this topic is making sure we use the right methods, the right formulas to work out the perimeters or the areas or the volumes, making sure we show working. This is really important for NCEA, and we start thinking about getting ready for next year and level 1. They don't like just seeing an answer. They do want to see you working. You won't get credit if you just write down an answer. So always write down the calculation you ask your calculator to do. Always write it down. Then you can get credit. And always make sure you write the units as well. So if it's a length, you're using units for length, like meters or centimeters. If it's an area, you're using units for area, like square meters, square centimeters. And if it's a volume, you'll be using units of volume, like cubic meters, cubic centimeters, that kind of thing. So they're the things we need to look for. And again, NCEA don't like it too much if you give an answer and you've not given the units. So working and units, really important for us. So I'm just going to run through a few examples of the sorts of things. And if you have any questions on the way, just let me know if there's anything that's not clear. So to work out the perimeter of this shape, we know that perimeter means the distance all the way around the outside. So we'd have to trace all the way around the outside, all the way around, and we've got to add up all those distances to take us from the beginning all the way around and back to where we started. We could choose any point to start with. It doesn't really matter, but we can choose any point we like to start with and get all the way back to the beginning. This shape, we've got a little bit of work to do before we start, because it appears like we don't know what this distance is at the bottom, and it appears like we don't know what distance this bit is up the side. But actually, if we think about it, we do, because if I drop down here, I know that this distance has got to be 3.1, and I know that this distance has got to be 3.8 because they are at the top. So because that's 3.8 and 3.1, I can add them together, and the whole number bit gives me a 6, and then the decimal bit gives me a 9. So I've got 6.9 there. And I can do something similar across for the other bit, because this is 3.7 here. This has got to be 3.7 on that bit. And because this is 3.4 here, this is 3.4 on that bit. So I've got 3.4 and a 3.7. If I add them together, I get 7.1. And once I've filled that in, I now can just go and add all the numbers up all the way around the outside. I'm not going to do that just now, but all you just do is and again, write it down in your calculator, 3.1 plus 3.4 plus, keep going all the way around the shape until you get back to this last bit, the 7.1. Add that on, and then you're back to the start. And because our question was in centimeters, our answer will be in centimeters. Okay, if you wrote all of that down, that's absolutely perfect. But you just got to think about how to get those missing lengths. Okay, so that's perimeter. Perimeter, just the distance all the way around the outside. For area, these are the four shapes really we've looked at. We've got a rectangle where we multiply the base times the height. Okay, we've got, and I've given that in algebra as well as in words, we've got a triangle where we do the base times the height and then divide by 2, or half the base times the height. We can write it that way in algebra. Base times the height divided by 2, that's the same thing. For a trapezium, we've got the two parallel sides. We add those together, we times by the height, and then we divide by 2. Okay, so we get it something looking like this. Do half of what a plus b is, and then times by the height. And the parallelogram formula is exactly the same as the rectangle formula. Just do base times the height. Base times the height, because you can think about it, this little triangle here, if I move him along, it gives me a rectangle. So it is the same really as the area of a rectangle. So we need to be happy with these formulas. Now, in the quick little progress check we do tomorrow, if you want to write those down to take them in with you so that you've got them there, you can remind yourself what to do. That's absolutely fine. This is an open book check-in. So there's nothing to say, you've got to remember all these formulas. If you want to write them down, the methods to do these things, then that's absolutely fine. I remember this video is going to go up as well on the Google Classroom, so it'll be there for you too. But writing those bits down can be really helpful just to help you remember what you do for what shape. But the nice thing is, if you look at what's coming out, the rectangle is base times height, the parallelogram is base times height, the triangle is base times height, but then we have to remember to halve it. And then we've got the base and the top part added together, half of that times the height. So there are some things that are similar in there. We're getting BH, 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 and BHs. And the rectangle and parallelogram are the same. The triangle is half that. The trapezium is the most difficult one to remember. But if you've written it down, you've got it there, you can use it. Then we came on to circles. And with circles, this is where pi got introduced. So if we were looking at circles, we could say the circumference is pi d, pi times the diameter, or 2 times pi times the radius, because the diameter is twice the radius. Remember, the diameter is all the way across the circle. So sometimes on these questions, we just need to be a little bit careful. Are we being told the diameter, or are we being told the radius? And just make sure we've got the right bit in there. And then it's just a case of using our calculators. So if I'm told I've got this circle, great circle, there's my center. This bit here is 10 centimeters. I've been told what the diameter is. So that's quite easy. I can just do pi times 10 on my calculator to get the circumference, because that's the way to work out pi times the diameter. So I'm just going to do that on my calculator now and pop that up on the screen. So if I do, let's just clear that, pi times 10. So if I'm going to give that to, where am I? If I'm going to give that to one decimal place, it'd be 31.4 centimeters. Again, write the units, write the calculation. If I want the area, I've got to remember it's pi times the radius squared, and the radius is half the diameter. So if my diameter was 10, my radius is 5. Pi times 5 squared will give me the area. So if I just do that one, pi times 5 squared, and again to one decimal place, that's going to give me 78.5, and because it's an area, it's square centimeters. Okay, so the key thing is just be careful. Do we need the diameter, which we do in the circumference formula, or do we need the radius, which is what we need in the area formula? And again, you can write those things down and take them into the test with you, so you've got them there, the quick quiz, so you can see what needs to be done. Then we went on to our three-dimensional shapes and looking at volumes. So I'm just going to go through how we work out the volumes of each one of these. So we've got a cuboid in the top left. So there's a cuboid. Okay, next to that, we've got a prism. And then underneath at the bottom, we've got a cylinder. And each one of these three, the different ways to work out the volumes. Cuboid's the easiest one. The volume is the length times the width times the height. Basically, the three numbers you see there, you're just going to multiply together. So for the cuboid, you do V is L times W times H. So calculator's fine for this. You do 10 times 4 times 5. Doesn't matter what order you multiply them in, because you multiply numbers together in any order you like. 10 times 4 is 40, times by 5, that's 200. And if we say that was in centimetres, then our answer should be in cubic centimetres. If we look at the prism's formula to get the volume is, volume is the area of its base times by its height. So on this one, for our prism, we can say the area of the base times by the height. We're told the area of the cross section is 30 square centimeters. Whenever you see something like that, it's just telling you what the area of the bit on the end is. What's the area of the cross section? It's called the cross section because it's just, we cut across the shape. We always get that pentagon here for this one. So prism would always have the same shape all the way running through it as its cross section. So for this one, what we're going to have to do, we're told the area of the cross section is 30, and the other distance that we've got, the height or the length of the prism, we can just times them together. So again, I'll just reach for my calculator to do that one. So I've got 30 times 12.5, 375. Okay, for that one, 375. And that one does tell us it's in centimetres, so that's good. We'll write cubic centimetres. And then for our cylinder is where we come in with pi again. Pi times r squared times by the height will give us the volume of the cylinder. We've got to be a little bit careful again on this one, because this one isn't telling us the radius. It's telling us the diameter. It's telling us all the way across. The radius then is 10, half of the 20. So the volume for our cylinder will be pi, we use the button on our calculator, times the radius squared times by the height. So if you're doing this with me, you might see how you get on. Pi times the radius squared, which is 10 squared, times by the height, which is 9. So if I just click that one in, we'll see what we get. So we've got pi times 10 squared times by that. Okay, and I've got quite a big number, 2827. And if I go to one decimal place again, it's 0.4. 2827.4 cubic centimeters. So our cylinder there, out of the three shapes, has the biggest volume. Okay, the cylinder's got the biggest volume. Then it would be the prism, and finally the cuboid's got the smallest volume. All right, so that's, those formulas again. If you need to write them down, take them into the quick quiz with you tomorrow when you're doing that, and just apply the right method. Okay, so it's all about using the right formula at the right time, writing down the calculation, put down the units. This is a tricky question. Okay, you can get questions like this. So we've got a rectangle which is around two identical circles. So this is more getting more into sort of how shapes come together to make other shapes. And it's asking us to say what the area shaded is. So the area shaded is what we've got when we take away the two circles from the rectangle. If we could work out the area of the rectangle, we can take away the area of the two circles, and that'll tell us what's left, the bit that's shaded. But do I know enough about the rectangle? Well, actually, if I think about it, I do. Because this, yeah, this, go on, you tell me.
Well, you just like see how like the radius of the circle is 5, so you just double that, and that's like the height, and then double the height is the width.
Yeah, that's right. Good job, Kalani. Okay, so you got 10 and you got 20 there. Okay, all the way across, because this is just the radius, isn't it? As you're saying. So that's 5, that's another 5, that's 5, and that's another 5. So you've got 10 by 20. So I know that for my rectangle, so if I'm going to write this down carefully, the rectangle's area is just going to be 200, isn't it? 10 times 20. Okay, so that's just 200. And if I want to think about the circle, I need to work out each circle and then subtract it away. So if I think about the circle, for one circle, I'd have to do pi r squared, pi times 5 squared. Okay, but for two circles, I'm going to have to double that. Yeah, I'll get twice as much. So I'm just going to say, we'll do it all in one go. 2 times pi times r squared will give me what the two circles would be. So I can just reach for my calculator and type him in. So my two circles, 2 times pi times 5 squared, 157 and a bit. Okay, so 157, if I do it to one decimal place, 157.1. And then to get the area that was left, the shaded bit, I just need to take them away. So if I just subtract those two numbers, that will tell me the area that I'm left with. So if I just do that now, so 200 minus the 157.1, you're probably ahead of me anyway, it's 42.9. So 42.9 square centimeters was the shaded bit. All right, work out the whole thing, the rectangle, then take away the two circles. All right, finally, a more complicated question about a triangular prism. So these are ones where sometimes they will tell you the volume and you have to work out missing lengths. This is a triangular prism. We know for a prism that the volume is the area of the cross-section times by the height. So I know that here, the 60, which it tells me, is what I get when I do the area times by 8. Okay, the 8 here is the bit that's running along, the height or the length. It's the length in this case, but same thing. So that allows me to work out what the area of the end shape must have been. This end shape has an area A, because I have to do that A times by the 8 to get the overall volume. So 60 is A times 8. I can work out A then by dividing by 8. So if I do 60 divided by 8, tells me it's 7.5. So I know, lost my pointer for a minute, I know that the area of the triangle is 7.5. But how do I get the area of a triangle? The area of a triangle is half the base times the height. So I know that 7.5 is half of the base. The base is 5. Half of the base is 2.5 times the height. So if I now just divide by 2.5, I've got the height. Another way of thinking about this, if that seems a bit tricky, I'll just come to it in a second. But if I do that division, I get 3. All right, do it on your calculator, 7.5 divided by 2.5. Another way sometimes of dealing with these things where they've got decimals in them and you don't like it very much, if you double both sides of the equation, the answers won't change. They will still balance. Whatever you do to one side of an equation, you can do to the other. So if I double the 7.5 and get 15, and I double the 2.5 and I get 5, that's fine. And obviously if I do 15 divided by 5, I get 3 as well. So sometimes you can find that a little bit easier to think about. So the height is 3 centimeters. And I'm just going to check right at the end, does it make sense? If I work out the area of my triangle is half base times height. So it's half times 5 times 3. I do that on my calculator or in my head. It gives me 7.5. So that seems okay. And then I know that my volume of the original shape is that area times by the height, or the length in this case of the prism. And if I do 7.5 times by 8, I do get 60. So I've checked back just to make sure that my answer of 3 does make sense. It does give me the right answer in the end. Okay, so those kind of questions are trickier because there's more stuff to do in there. It's brought in prisms and it's brought in triangles and it's trying to get you to work out missing lengths. They are trickier questions, all right? They are higher level questions. So what I've set up for you today, if you want to have a look, I've created everybody in the class an account on Dr. Frost. What it doesn't have at the moment, unless you've been in there already, it doesn't have a password for you. There is the link that I'm showing on the screen there that is in the classroom. If you just click on that link, it will take you into Dr. Frost, to your account, and you can then just say, well, I'd like to use this password. You'd say what password you like. Or you can link it to your Google account using your school email, and that means you won't ever have to type a password in. Okay, so just go to that link, click on it, and you will either set your password or go to your, or say, I want to use the Google for logging in. That's going to be fine. Then there's some questions called measurement review, which you'll see pop up for you. That task will appear for you on your dashboard when you've signed in. And you can practice the questions you think you most need to. I've given a mix of questions in there, so you don't have to do them all. It's just there to help you practice for tomorrow. You can practice the area questions, the volume questions. You can practice the more difficult questions like the one we did at the end. And there'll be a mix of questions in the progress check tomorrow as well, okay? There won't be so many difficult questions. They'll mainly be the straightforward questions, but towards the end, a couple of the questions are a bit more difficult. All right, so the key thing is to focus on those ones early on and make sure you've got the formulas right and you've got them absolutely nailed. All right, so if you want to take the formulas in to the quiz tomorrow, that's absolutely fine. It's an open book check, so it means, anything you want to take in there written down to help you, it's great, do it. The key thing is, do you know what you're doing? Do you know which ones to use? Can you do the calculations right? So don't worry about having to remember all the formulas. You don't need to do that. Okay, you can take those in with you. Does anyone have any questions? No?
I'm gonna come in now, but
It's probably a bit too late. Is that Riley now? Just joined us. Hello, Riley. I think you've just about missed what we've been through. We've just about come to the end. But this video is going to go up on the classroom in a minute, so you'll be able to play back and have a look at what we were looking at. But the key thing is just put on there that in the classroom as well, there is this link for you to connect through to your new account on Dr. Frost. Click through it. It'll take it straight through. Your account's already set up. It just wants to know what password would you like to use, or do you want to use your Google account with your school email address, because then you will just get straight through without having to put a password in. And there's these few questions to have a go at. Pick the ones you want to have a go at. And then tomorrow, it's just a quick check-in to see how well you're doing across the topic. So there's a little open book test. You can take along formulas with you if you want to do that and just work through the questions. Okay? So if everyone's okay, I'll leave you there for now. There's nothing else to do. We're not doing anything else before we go back to school now, apart from just this little bit of practice and that check-in to see where we are, because that'll just help us when we get back into school. We'll know where everyone is and if there are any bits we just need to brush up on a little bit, or if everyone's happy across everything we've been looking at while we've been on lockdown. Okay, so that's it for today. Thanks for joining. Any questions, obviously, fire them to me at any point. That's all good. And I look forward to seeing you. Well, actually, I know I will see Kaya on Monday, but I won't see you in maths, will I, until Tuesday. So look forward to seeing you all then. Okay, everyone. See ya.